Hello, I'm Lauren. I'm a PhD student working on the AgriWasteValue project. My work consists to develop green processes for the modification of natural extracts or molecules to bring them new added value and then to characterize the new compounds produced. My PhD is in co-direction between two partners of this project, the URD ABI of AgroParisTech and the ECMR of the University of Reims Champagne-Ardenne. So we are here at the URD ABI, the lead partner of the project, which is located to the European Center of Biotechnology and Bioeconomy near Reims in France. It's a research and development unit dedicated to the sustainable production of high added value bio-based chemicals using biotechnology, green chemistry and downstream processes. Our role through the green chemistry department is to produce new bioactives for cosmetic and nutraceutical sectors by modifying natural extracts using biocatalysis and then identify the new molecule produced by LC-MS analysis. We are in step 3, synthesis, modification and characterization of natural molecules. Following the extraction step performed by our partner Celabor, we study the enzymatic modification of the bioactive molecules present in these natural extracts. More precisely, we focused on the enzymatic glycosylation, which is a common modification to increase the water solubility of molecules and facilitates their incorporation in cosmetic formulation. The modification of bioactive by green processes is a very interesting part of the project valorization chain to potentially offer new applications to natural molecules by modifying or increasing their properties. As a first step, we synthesize by green chemistry 24-chalcone and dihydrochalcone as analog of fluoretine, which is an interesting compound found in apple tree roots. Then we have chosen 3 promising candidates, 1 chalcone and 2 dihydrochalcone, and submitted them to enzymatic glycosylation. At this stage of the project, we scaled up the reaction in this 10 liters reactor. We are now able to glycosylate 10 grams of molecules or extract and produce glycoside with a yield of 30%. The reaction medium was then analyzed by LC-MS. The results show that we obtain mainly mono and diglycoside, but we also observe molecules glycosylated at least up to 5 glucoses. The enzymatic glycosylation protocol was applied to the Celabor extract enriched in fluorescein and recovered from apple tree residue. The results already obtained are very promising, and we identify many different types of glycoside that remain to be fully characterized. After the enzymatic reaction, the medium must be purified to characterize each glycoside produced. This step is done at the ECMR, the second laboratory where I work. We are here at the Institute of Molecular Chemistry of Reims, located on the Science Campus of the University of Reims Champagne-Ardenne. It's a joint research unit associated with the CNRS, whose activities are organized through 5 different research teams. The team directly involved in this project has a strong expertise in natural product chemistry, including fractionation and computer-assisted structural elucidation. Therefore, the role of the ECMR through my PhD logically concerns the isolation and the elucidation of the structure, mainly based on the NMR data of the compound produced during the enzymatic reaction. After the extract modification step performed at the URD ABI, we obtain a complex mixture composed of the starting product and many different glycosides. that must be purified for their characterization and their biological activity evaluation. Isolation and identification steps are mandatory for the development of new bio-based ingredients for cosmetic and nutraceutical sectors. Centrifugal partition chromatography, or CPC, was used for the fractionation of the different types of glycoside obtained from the enzymatic glycosylation. It's a preparative, support-free, liquid-liquid chromatography technique based on the difference in partitioning behavior of analytes between at least two immiscible phases. Within the framework of this project and considering its environmental impact, an original green biphasic system was developed composed of CPME, ethanol and water, and proved to be very efficient for the separation of the different types of glycosides. After additional purification step using preparative and semi-preparative HPLC techniques, about 20 new molecules was isolated, resulting from the enzymatic glycosylation of the chosen candidates among the chalcone and the dihydrochalcones. Then, their respective structures were established by NMR and MS analysis. These results were obtained thanks to the NMR platform available at URCA, and especially to the 600 MHz NMR spectrometer equipped with a cryo probe, improving the quality of the recorded spectra. Finally, the isolation and the identification of new compounds with high potential and a large structural diversity has led to initiate fundamental researches which are currently ongoing to understand the mechanism of the enzymatic glycosylation and the chemical nature of the resulting glycosides. Once the compounds are isolated and identified, we can assess their biological properties such as antioxidant and anti-tyrosinase activities. Discussions are also ongoing with partners of the cosmetic and nutraceutical sectors for the test of these compounds and to evaluate their potential as ingredients for these fields.